So in this final section on computational strings, we're going to learn the last skill that we're going to need for our poetry mini project, which is list manipulation. So at the end of this lesson, you should be able to select parts of a list or a nested list, and you should be able to construct and organize a list or multiple lists. So let's start out with making lists. We've seen a lot of ways to make lists so far. We can just write one out, and as we know, lists can contain any number of things of any type, and they start and end with a curly brace. Many functions have lists as their output, like range, random color, and alphabet. Some other interesting functions with lists as their outputs are things like integer digits and characters, which break up a number or a string. So if I do integer digits of 1998, then I get the list of integers within that number. If I do characters within the string Wolfram, then I get a list of the characters within that string. And of course, we can generate lists using table. So if I do table of anything, and I can ask table to do anything to my variable, and then I ask it to do it, for example, within a range, then it's going to return me a nice list. Now let's talk about getting elements of a list. So if we want to get a specific item in a list, there are several different ways that we can do that, depending on exactly what we want. If we're specifically looking for the first or the last element in the list, then we can use the function first or the function last. The most general function for getting elements of a list is part, which returns the element at a specific position. So we can say part of a list, the second one please. It'll give us the second part of that list. Part is more commonly written with the shorthand double square braces, so because it's quicker. So if I give it a list and I say I would like the second part of that list, it'll give me the second part of that list. We can also use part to get multiple elements of the list. So for example, we can use double semicolon, which means span. So I can get parts of the list 2 spanning to 5, so numbers 2, 3, 4, and 5. And that returns the second, third, fourth, and fifth item in the list. We can use the function take to do the exact same task. So take returns the first n elements in the list. So if I do take the first 2, then I get the first 2 items in the list. Or we can ask it to take the last n elements in the list, just using minus. So if I do take minus 2, I'm going to get the last 2 elements in the list. Similarly, I can get elements n through m in a list. So if I take the second to the fifth items in the list, I'll get the second through the fifth items in the list. So drop, on the other hand, returns the list with the first n elements dropped. So everything other than the first n elements. So in this case, if I said drop the first 4 elements, it gives me the final 2. Or it can do the last n elements dropped with the minus sign, just like for take. So if I ask it to return the list with the final 4 elements dropped, then it returns the first 2 elements. Drop can also remove an element at a specific position. So if I put it in curly braces, I say I'd like you to remove the 4th element from the list, then it removes the 4th element of the list. Some other ways to manipulate lists are things like min and max, which return the smallest and the largest element in the list. So all of that was helpful for single lists, but we can also have lists of lists. We might get a list of lists by writing out coordinates, and if we want to get the second coordinate, the second list in the lists of lists, then we use part just like normal. So the second element of this list is the list 2, 2. If we want to get the first x value of the second coordinate, then we would use part twice. So I want the second element of the list, which is 2, 2, and I want the first element of that, which is 2. And if we want the first element of each list, then we can use part along with the function all. So if I say I would like all of the first parts, then I get all of the first parts, 0, 2, and 2. So let's move on to sorting a list. So the most obvious function for sorting a list is sort, which returns the sorted version of the list. Sort is also going to put strings in alphabetical order, and we can use reverse sort to get the sorted order from largest to smallest. so we don't have to sort it and then reverse it. Another thing that we might want to do with a list is counting. So we might want to find out how many elements are in a list, which we've done lots of times before, and we could do that using length. We might also want to find out how many times a particular element appears in the list. So the function count takes a list, and it takes the thing that you're looking for, the thing that you would like to count, and in this case it's going to count how many red squares are in my list, which in this case is 9. Or we might want to know how many times every element appears in the list. In this case I could use the function tally, which is going to tell me that I have 9 reds, 12 blues, and 4 yellows. So those are some really helpful counting functions. Beyond sorting lists, we might need to split lists up or merge multiple lists together. So let's have a look at rearranging lists. The first thing that we might want to do is merging. One of the most useful functions for working with lists is flatten. Flatten flattens out nested lists into one big list. So if I give it a list of 2 lists, it gives me back one list. Join does a very similar thing by taking multiple lists and joining them into a single list. There are various reasons why you would use flatten or join in different ways. Riffle takes 2 lists and intersperses them so that you get the first element from the first list and then the first element from the second list and so on. So you get to intersperse those lists. And as we've seen before, we can use riffle to put a single element in between all the items in a list. So in this case I wanted to put black in between all of the items in the list, and now every other item in the list is black. Now let's work on splitting lists into different smaller lists. So one of the easiest functions we can use is partition, which breaks a list into smaller lists with a specific length. So if I have my list here and I say I'd like you to partition it into lists of length 2, then we can get 3 lists of length 2. If we have a list with lots of repeating elements, then we can use split to split the list into smaller lists containing runs of the same element. So in this case, I have runs of the same element, and so I'd like to split the list into all of the first element, then all of the second element, then all of the third element. And I can do that using split. If our repeating elements aren't in order, then we can use gather to sort and split at the same time. So now I have this crazy list that has colors in lots of different spots. I would like to gather like ones together and split them into different lists, and I can do that using the function gather. So what if I wanted to delete all the duplicates in a list? So we could do something complicated like using gather to gather all of my series together, and then I would have a list of reds, a list of blues, and a list of yellows, and then I could just get the first item in each of those lists. So now I have a red, a blue, and a yellow, and all of my duplicates have been deleted. Or we could make it nice and easy for ourselves, and we can use the delete duplicates function. So the delete duplicates function just deletes all of the duplicates. And now I have my list of red, blue, and yellow. So in this lesson, we've covered some basic list manipulation, and our key takeaways from this lesson are that lists are a collection of things. There are lots of different ways to generate lists and functions that output lists. We can get one element or a section of elements with part, and other related functions include first, last, take, and drop, and we can use part on nested lists. We can rearrange items in multiple different ways. In this lesson, we learned how to organize a list with sort, count elements in a list with count or tally, combine lists with flatten, join, or riffle, split a list with partition, split, and gather, remove duplicates with gather, and delete duplicates. So again, we've learned a huge amount today, and you should now be ready to do the mini project for this section, so I hope that you have a great time writing some computational poetry.